In this video, we're going to take a look at some of the methods for counting techniques. Specifically, we're going to be looking at tree diagrams and counting techniques. Now, basically, the idea with tree diagrams and counting techniques is that calculating probabilities is easy enough if you know the total number of possible outcomes, if you're calculating theoretical probabilities. But in some scenarios, it's not immediately obvious how many possible outcomes there are for a given scenario. And so we need some techniques or some methods to actually do that kind of counting, to figure out how many possible outcomes are we taking this out of. Now, if we take a look at something called the multiplication rule of counting, this is one method for coming up with possible total number of possible outcomes. And the multiplication rule of counting says to consider the series of events E sub 1 through E sub m. So basically we've got a series of events, event number 1, then we could have E sub 2 representing event number 2, E sub 3, event number 3, all the way through E sub m. If we had 50 events, this would be E sub 50. And then where n sub 1 is the number of possible outcomes for event E sub 1, n sub 2 is the number of possible outcomes for event sub 2, and so on. Then the product, n sub 1 times n sub 2 times dot 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 all the way through n sub m, if there are m total events, gives the total number of possible outcomes for the series of events E sub 1 followed by E sub 2 up through event E sub m. Okay, that's what the multiplication rule of counting says. Now, this is one of those times in mathematics where we have this description of something that's actually a lot more complicated than what the computation would suggest. So I'll give you an example of how to apply this that hopefully will make it a little bit more straightforward. Let's imagine that we own a pizza parlor. Actually, let's make it fancy. Let's make it P-A-R-L-O-U-R, parlor. Okay, pizza parlor. And let's say that at our pizza parlor, we have 3 different kinds of crust. Let's say we've got 4 sauces that people can choose from and maybe 12 toppings. Okay, 3 crust, 4 sauces, 12 toppings. And let's say that we wanted to create an advertisement for our pizza parlor. And we want to advertise our pizza parlor by how many different pizzas you can make. So we might want to ask ourselves, how many different one-topping pizzas can be made? Okay. So this is essentially like saying how many possible outcomes are there if the event that we're interested in is making a one-topping pizza. How many different possible outcomes are there for that particular event? Now, according to the multiplication rule of counting, we should be able to take different events and multiply their number of possible outcomes together to get this total number of possible outcomes for a series of events. Well, if we think of creating a pizza as a series of events, where first I'm going to pick my crust, then I'm going to pick my sauce, and then I'm going to pick my topping, which I'm only doing once if I'm making a one-topping pizza, then I can think of this as a series of events. Now I have 3 choices for crust, 4 choices for sauce, and 12 choices for topping. And according to the multiplication rule of counting, to get my total number of possible outcomes for 3 crust choices followed by 4 sauce choices followed by 12 topping choices, I simply multiply these together. And if I do that, 3 times 4 times 12, I find out there are 144 different one-topping pizza combinations that I could make with this particular set of data. Now, if I wanted to expand this and ask what would be the case for 2 toppings, all we would need to do, crust, sauce, topping number 1, topping number 2, crust, sauce, top number 1, top number 2, 3 crust, 4 sauce. I have 12 choices for topping number 1, but then to make a true 2-topping pizza, I would need to pick a different topping for topping number 2, so I would then be down to only 11 choices. And 3 times 4 times 12 times 11 is 1,584. There are 1,584 distinct 2-topping pizzas that we could make with these constraints. Okay, and that's how the multiplication rule of counting works. It's relatively straightforward, and it helps us determine, how many possible outcomes we have. If I wanted to know what was the probability of creating a pizza that had, a thin crust, spicy sauce, pepperoni, and olive, well, there's only one possible pizza that does that out of the 1,584, and so I could get my probability that way. So that's how we can apply the multiplication rule of counting to coming up with probabilities. In the next video, we'll take a look at using tree diagrams to not only order our sample space and come up with our total number of possible outcomes, but also use it to calculate probabilities.